All right, let's go ahead and take a look at just one of these easy ones on the front. So let's do number 3. All right, for number 3, go ahead and take inventory of it. You got mercury and oxygen. Only 2 elements there. All right, how many mercuries do you have on the left? Just 1. How many do you have on the right? Also just 1. How many oxygens do you have on the left? Just 1. How many oxygens do you have on the right? You got 2. So the only thing that's out of balance here is my oxygen. So if I have 2 over here, I want 2 over here, what do I need to put in this slot? Put a 2. That changes my oxygen to 2. It also changes my mercury to 2. So it balances my oxygen, but it unbalances my mercury. So what do I have to put right here? Put a 2. So if you do that, that'll balance out the whole thing. Give me 2 of each type of atom. All right, everybody good with that? Okay, go ahead and flip 2 pages over to page 9. All right, for page 9, let's go ahead and do number 13. So you have potassium, phosphorus, oxygen, hydrogen, and chlorine. Quite a few elements here. Again, the number of elements does not always mean it's hard or easy. So there's a lot of elements here, but this one's not that hard to balance. So on the left, we have 3 potassiums. On the right, we have 1. On the left, we have 1 phosphorus. On the right, we have also 1. On the left, we have 4 oxygens. On the right, we also have 4. All right, on the left, we have 1 hydrogen. On the right, we have 3. And then on the left, we have 1 chlorine. And on the right, we have also 1 chlorine. So the only thing that's out of balance here are my hydrogen and my potassium. So I would go ahead and balance the potassium first, but it really doesn't make that big a difference in this case. So potassium, I have 3 over here. What do I need to put right here to give me 3 potassium? Put a 3. 3 times 1 is going to give me 3. Now, that also changes my chlorine to 3. 3 potassium, 3 chlorine. Now, I need to balance out my hydrogen. So I have 3 hydrogen on the right. What do I need to put right here to give me 3 hydrogens on the left? Put a 3. Now, when I put that 3 there, that changes my hydrogen to 3. It also changes my chlorine to 3, which balances everything. So there you go. These would be 1s. The 1, 3, 3, 1 would be your coefficients there. All right, anybody have any questions so far? All right, go ahead and flip the page. I'm going to teach you a couple things here, a couple little tricks. All right, now you see how right here you have this SO4 unit, and right here you still have that same unit over here. It doesn't break up, doesn't change. It's still SO4. Okay. You don't have to break those into individual elements and say sulfur and oxygen. If that's the case, like there's the same thing down here. You have SO4. Over here you still have SO4. If you see that, you can like tally that up as one thing rather than breaking it into the individual elements. Now it doesn't always work. Like right here, you have OH. This is hydroxide. That does not look the same over here. So I would not do that here. But in ones like these where you have same unit together right here and right here, you can like keep that together. So what I'm talking about is when I tally this up, I would have aluminum, bromine, potassium, and then I'm going to consider SO4 to be one thing because you can't really split it up in this compound or in this equation because it stays together. So if we tally up how many we have of each one, how many aluminums do I have on the left? Just one. How many do I have on the right?
One. Wait, no, two.
Two. That two right there tells me there's two. How many bromines do I have on the left? Three. How many on the right? Just one. How many potassiums do I have on the left? I have two. How many on the right? Just one. Now, how many SO4s do I have on the left? SO4s as a whole, that's sulfate. I only have one. If it's not in parentheses, you only have one of them. Now, on the right side, how many do I have? All right, you're looking at just the oxygen, but the SO4 as a whole, I only have three. Because remember, we're not breaking this up right here. If I broke it up into sulfurs and oxygens by themselves, that would be different. I would have 12 oxygens, but SO4s as a whole, I only have three. All right? Everybody with me? So I would just go right down the line. Aluminum, I have one on the left, two on the right. So what do I need to put right here? Put a 2. That gives me 2 aluminums. It also changes my bromine to what? 2 times 3 is 6. So that's definitely different. Now, I would go ahead and balance out my... I actually would not do my potassium yet. And here's why. I have 2 potassiums here and 1 over here. If I put a 2 there, I'm going to have to change it because I have 6 bromines on the left and only 1 on the right. So I would go ahead and do that first. So if I have 6 bromines over here, 1 over here, what do I need to put right there? 6. And that's going to change my bromine to 6. It also changes my potassium to 6. Now, what do I need to put right here to give me 6 potassium? What times 2 equals 6? 3. So if I put a 3 right there, that gives me 6 potassiums. But it also changes my sulfate, my SO4. I now have 3 of those. Because I had 1 in the beginning, so 3 times 1 is 3. So that balances out everything. All right. Anybody have any questions over that one? All right. I'm going to show you one more. Go ahead and flip to page 11. We're going to take a look at number 23. Okay, this one is hard. All right. So if we tally up the things we have carbon, hydrogen, and oxygen. Now, how many carbons do I have on the left? 2. How many do I have on the right? Just 1. How many hydrogens do I have on the left? 6. How many do I have on the right? Just 2. How many oxygens do I have on the left? 2. How many do I have on the right? 3. All right. I got these in 2 different places, so 2 plus 1 gives me 3. All right. Now, this gets tricky eventually, and I'll show you a little trick to help you get through this. So, I would balance my carbon first. So if I have 2 over here, what do I need to put right here? Put a 2. 2 times 1 gives me 2. And that also changes my oxygen. So 2 times 2 is 4, plus the 1 here, that gives me 5. 5 oxygens. All right. Now, I have 6 oxygens on the left. I only have 2 on the right. What do I need to put in this slot to give me 6? 3. So that gives me 6 oxygens. And it also changes my, I have 6 hydrogens. It also changes my oxygens though. So now I still have the 2 times 2 here, which is 4, plus 3 more oxygens here, which is 7. All right, everybody with me in how I got that?
No.
Look, I put a 3 right here. That gives me 3 oxygens here, right? 3 times 1. And then I still have the 2 times 2 here. 2 times 2 is 4. 2 times 2 is 4. Plus the 3, that's 7. You got to total them up. Okay? Now, here's the thing. Can you ever get an odd number by multiplying 2 by anything? That's a whole number. No. I can multiply 2 by whole numbers till the cows come home, and I'm never going to get an odd number. So can I ever get 7 out of this? No, I cannot. So the last thing that I need to balance is my oxygen right here. Well, here's a little trick. And this happens sometimes, especially with these combustion reactions like this where you have like diatomic oxygen. What you can do is you can double everything else except for that last spot and then balance it from there. So if you put a 2 here, make this a 4 and make this a 6. Okay, 2, 4, 6, just double everything. That will also double everything down here. Gives me 4 carbons, 12 hydrogens, 12 hydrogens. And then it also doubles the oxygen in the last spot. So it gives me 14 instead of 7. Now that's an even number. So what times 2 equals 14? 7. So if I put a 2 right there, that gives me 14, and now it's balanced. 2, 7, 4, 6. That would be my coefficients. All right, anybody have any questions? Okay, what I want you to do for tomorrow is the easy ones. All right, just the